So this is 5.2.1a. We have x, which is distributed normally. We have a mean of 3.2 and a variance of 6.5. Y is normally distributed with a mean of 2.1 and a variance of 3.5. So this means we could write off here to the side that the expected value of x is 3.2. The variance of x equals 6.5. So I find it useful to write things out. The expected value of y equals negative 2.1, and the variance of y equals 3.5. Now, we want to find the probability that x plus y is greater than 0. So whenever I'm dealing with combinations, I like to just write a new variable. So I'll just say w equals x plus y. You can pick any name. I just picked w here. So we need to find the new mean and the new variance. So find the mean and variance of w. So the expected value of w is the expected value of x plus y. We use our rules from section 2.6 to do this. So the expected value of x plus y should just be the expected value of x plus the expected value of y. So this would be 3.2 plus negative 2.1, which gives me 1.1. The variance for our new combination, the variance of w, would be the variance of x plus y, which equals the variance of x plus the variance of y. Well, the variance of x is 6.5. The variance of y is 3.5. Which gives me, that should be 10. So remember, all of these rules for your expected value and variance come from section 2.6 in our book. Here you're looking for combinations for expected value and variance of random variables. So we now have an expected value of w and a variance of w. Now that we have those, we just do this like any other normal distribution problem. So w is normal. With a mean of 1.1 and a standard deviation of 10. Sorry, a variance of 10. Now we do a normal distribution problem. So the probability that w is greater than 0. First, we have to find our z value. So z is always equal to your x value minus the mean over the standard deviation. So in our case, instead of x, we have our w here. So we'll put the 0 minus the mean for w's, which is 1.1, divided by the standard deviation. We don't know the standard deviation yet. So if the variance is 10, the standard deviation will be the square root of 10. So over the square root of 10, which gives me negative 0.35. So if I was to draw a picture, here is my z equals negative 0.35. I want all the area to the right. So I pull up my normal table. I'm looking for negative 0.35. So negative 0.30, 1, 2, 3, 4, 5. Looks like it'd be this 0.3632. But that's the area to the left. Our normal table always gives us area to the left. We wanted the area to the right. So 1 minus that 0.3632 gives me 0.6368. You'll notice that's slightly different than what you get in the solutions manual just because they didn't use the table, they used the calculator. So again, to recap, if you want to find probabilities with some combination of random variables, just say, okay, I have a new random variable, w. Find its expected value, find its variance using those rules for combinations of random variables, and then it's like any other normal distribution problem. You need to standardize, look it up on the table, there's your probability.